look up at the night sky, and almost nothing about it feels temporary. The stars do not seem hurried. The darkness between them does not suggest fragility. Even when we learn, in the abstract, that the universe changes, the mind still resists the idea that the cosmos could already be moving through some kind of ending. It feels too immense for that. Too old. Too steady. Too full of light. The universe seems like the sort of thing that simply goes on. And yet one of the strangest things modern astronomy has taught us is that this impression may be deeply misleading. The universe is not only changing, it may already be living past its brightest era. There may once have been a time when the cosmos was more fertile than it is now, when galaxies turned cold gas into new stars more readily, when light was being born across space with a greater intensity than anything typical of the present age. If that is true, then the end of the universe may not be a single catastrophe waiting far ahead. It may be something quieter and much harder to notice from inside. A long dimming, a slow reduction in the conditions that once made the universe feel young, active, and full of becoming. That is the contradiction at the heart of this story. We live in a universe that still appears immense and alive, and yet the science suggests that its richest age may already be behind it. We can estimate its age, trace its expansion, reconstruct parts of its early history, and describe much of its large-scale structure with real confidence. But when we ask where all of this is leading, the answer becomes less settled. The deeper we look, the more the universe seems to hold two truths at once. It is majestic, ordered, and full of motion. And it may also already be drifting through the long fading of everything that once made it most luminous and generative. So tonight we are not beginning with a dramatic ending. We are beginning with a quieter possibility. What if the universe does not die all at once? What if, instead, it slowly grows quieter? What if the sky above us, so full of apparent permanence, belongs not to a cosmos near its beginning, but to one already living in the late light of its own history? For most of human history, the sky gave very little reason to imagine a universe with a biography. The stars returned in familiar patterns. The constellations held, even when a comet appeared, or some bright wandering object startled observers for a season. The larger order still seemed stable. The heavens might be mysterious, but they did not yet feel historical. They did not seem like something that had passed through different ages, or something that might one day pass beyond the kind of universe we know now. The night sky was a scene, not a chapter. That began to change when astronomy slowly pulled the cosmos out of habit and into measurement. Once astronomers learned that distant galaxies were not fixed in place, but receding from us, and that space itself was expanding. The universe could no longer be imagined as a static backdrop. It had a past that differed from its present. It had moved from one state into another. And once that realization took hold, something else followed. If the universe was once different, then the universe we see now is not the whole story. It is only one moment inside a much larger process. That shift changed the emotional meaning of the night sky. To look upward was no longer only to look outward into distance. It was also to look into time. The deeper astronomers peered, the more they found that the universe had not always looked like this. The earlier cosmos was more turbulent, more crowded, and more eager in its transformations. Galaxies were smaller, less settled, often more chaotic. Gas was more abundant. New stars were born more rapidly. Whole regions of the young universe were alive with a kind of productive restlessness that feels, from where we stand now, almost extravagant. Astronomers sometimes describe this history in terms that sound almost poetic, though the science behind them is precise enough. There was a cosmic dawn, when the first stars began to shine after the long, dark period that followed the beginning. Later came what is often called cosmic noon, the era when the universe reached its great productive peak, when star formation was happening across galaxies at rates far higher than those typical of our present age. These phrases endure because they capture something real. Once the universe has a dawn and a noon, it can no longer feel ageless. It can have an afternoon. It can have an evening. It can move not only from simplicity into richness, but from richness into decline. And that decline is not just a metaphor. It appears in one of the clearest large-scale patterns modern cosmology has uncovered: the history of star formation across cosmic time. Early on, the rate of star birth rose. Galaxies gathered gas, collided, grew, and blazed with new activity. Then, several billion years after the Big Bang, that rate reached its peak. Since then, the overall fertility of the cosmos has been falling. The universe still forms stars. Light is still being born, but not with the same abundance, and not with the same ease as in those earlier ages. That is the thought that quietly changes the sky. The universe has not gone dark. It has not stopped. But it may no longer be living through its brightest moment of becoming. And once that idea settles in, the heavens start to feel subtly different. Not empty, not doomed in any sudden sense, but older, more like the sky of a universe that has already passed through an age of greater abundance and now continues onward with less of it. We tend to imagine ourselves, almost instinctively, near the beginning of cosmic possibility, simply because the universe is so vast and its future appears so long. Yet in another sense, we may already live after something important has passed, after the Great Surge, after the richest era of formation, after the time when the cosmos most readily turned matter into brilliance, gas into stars, and young galaxies into crowded engines of light. If that is true, then the phrase "the end of the universe" begins to shift in meaning. It no longer sounds only like a final event waiting somewhere ahead. It begins to sound like something that may start much earlier, when abundance gives way to a long narrowing of possibilities. That is why the idea of an ending can be deceptive. We often imagine an ending as a dramatic instant, but many endings do not begin with collapse. Some begin quietly, with the loss of conditions. Some begin when creation becomes more difficult than it used to be, when what was once common becomes rare, when the structures around us remain visible, but the forces that once renewed them begin to weaken. By that measure, the story of the universe's ending may not belong only to the unimaginable far future. It may have started long ago. In the moment the cosmos moved past the age of its greatest fertility and entered a later season of itself. But that naturally raises another question. If the universe has indeed moved past its peak, what changed? Was this decline imposed from the largest scales, by the overall evolution of the cosmos itself? Or did galaxies begin to grow quiet from within? To understand that, we have to move closer, away from the universe as a whole and into the inner life of galaxies, where the fading becomes not just a broad pattern, but a physical process. A galaxy can look serene from a distance. Across millions of light years, it appears as a shape, a glow, a luminous island of order set against the dark. But that calm appearance hides something more delicate. A galaxy is not simply a vast container filled with stars. It is also an environment in which stars are either still being made or are no longer being made, depending on whether certain conditions survive inside it. Gas must remain available. It must cool enough to collapse. It must avoid being heated, scattered, consumed, or driven away. The difference between a galaxy that continues to produce new light and one that does not is the difference between a place where birth continues and a place where that possibility has begun to close. This is where the larger story becomes more intimate. The fading of the universe is not only something written across immense timescales or visible in broad statistical patterns. It also unfolds within galaxies one by one, as their internal conditions begin to change. Astronomers use a stark word for this process: quenching. A quenched galaxy is not empty. It can still contain hundreds of billions of stars. Its old populations continue shining, and from a distance it may appear magnificent. But the essential change has already happened. The making of new stars has slowed drastically or stopped. The galaxy has, in that meaningful sense, gone quiet. That matters because it shows us that cosmic decline is not just a philosophical mood we project onto the sky. It is measurable. It has mechanisms. It leaves consequences behind. And perhaps most strikingly, it can happen surprisingly early. One of the most remarkable glimpses of this came from the James Webb Space Telescope, which found evidence of a quenched galaxy from when the universe was only around 700 million years old. That is an astonishingly early moment in cosmic history. The universe itself was still young by any grand measure, and yet in at least one place, the conditions for vigorous star formation already appear to have faded, before the cosmos had advanced very far into its long life. A pocket of quiet had already emerged. That single observation changes the feeling of the story. It suggests that decline was not merely waiting at the far edge of time for the universe to grow old in some obvious way. In certain places, the movement toward quiet began almost as soon as galaxies themselves had taken shape. The universe did not first enjoy a long, even age of flourishing everywhere, and only later begin to dim. Instead, the history seems more uneven, more layered, and more strange, even while the broader cosmos still belonged to its youthful eras. Some galaxies were already losing the conditions that made them fertile. Why that happens does not reduce neatly to one cause. And that complexity is part of what makes the story more compelling. Galaxies do not all grow quiet in the same way. Some may lose or exhaust the cold gas needed for star formation. Some are reshaped by bursts of stellar feedback, as young stars and supernovae heat the surrounding medium and make future collapse more difficult. Some may be influenced by mergers, interactions, or the activity of the enormous black holes at their centers. In other words, the fading of the universe is not simply a matter of one external force acting uniformly on everything. It is also built out of local histories and internal turbulence, and of the strange fact that the processes which create brightness can, over time, help undermine the conditions for more of it. That is one reason this topic resists any simple version of itself. If all we knew was that the universe had passed its peak of star formation, we might be tempted to imagine one clean explanation, one great cosmic law slowly lowering the lights. But the reality appears more layered. Galaxies are not merely passive things waiting for fate to arrive from the outside. Their own activity matters. Their own forms of success matter. Their own internal violence can contribute to the loss of future creation. The universe's fading is written both across the large architecture of space and inside the life cycle of the structures within it. And yet even that is not the whole picture. If the story ended there, we might still imagine the future as the gradual sum of many separate quietings. Galaxies slowly exhausting themselves one by one, while the larger cosmos simply provided the stage. But modern astronomy uncovered something stranger than that. There was another discovery, one of the most surprising in all of cosmology, that changed the meaning of the future altogether for a long time. The natural assumption was that although the universe was expanding, gravity would at least work against that expansion, slowing it down over time. But the deeper observations led somewhere else. The universe is not merely expanding, its expansion appears to be accelerating. And once that was understood, the fading of galaxies could no longer be seen only as the quiet result of local processes and dwindling supplies. It became part of a larger and stranger story, one in which the future of the cosmos is shaped not just by what galaxies do with their own gas and light, but by something embedded in the fabric of the universe itself. The discovery came as a quiet reversal. For much of the 20th century, once astronomers accepted that the universe was expanding, the question was no longer whether space was stretching, but how that stretching would evolve. The natural expectation was that gravity, acting across the immense web of matter, would slowly resist the expansion and temper it over time. The future, whatever its exact shape, appeared likely to be a story of gradual slowing. That expectation did not survive the late 1990s. Two teams of astronomers, studying distant exploding stars known as Type 1a supernovae, were trying to do something delicate. These supernovae are useful because they shine with a fairly consistent intrinsic brightness, which allows them to function as cosmic markers. By comparing how bright they ought to be with how bright they appear, astronomers can estimate their distances, combined with redshift. This offered a way to reconstruct how the expansion of the universe had changed over time. The assumption, quietly built into the work, was that these measurements would show a cosmos still expanding, but doing so ever more reluctantly. Instead, the distant supernovae appeared dimmer than expected. They were farther away than they should have been in a merely slowing universe. The implication was astonishing. Expansion had not been steadily losing momentum. It had, at some point, begun to speed up. There are discoveries in science that add detail to an already stable picture. And then there are discoveries that quietly rearrange the emotional architecture of a subject. This was one of those, because once the expansion of the universe is accelerating, the long future no longer feels like a simple matter of matter spreading out and slowly using itself up. Something else has entered the story. Something large enough to shape the fate of the cosmos, and strange enough that even now it remains more a name for a problem than a fully understood thing. We call it dark energy. That influence changes the meaning of decline. Before this discovery, one could imagine the universe as fading as a broad exhaustion. Galaxies would age, fuel would thin, new stars would become less common, light would continue, but with less replenishment. Acceleration adds another layer. It suggests that the large-scale universe is not simply coasting toward quiet. It is being drawn toward greater separation. Structures that are not tightly bound together are carried farther apart as time goes on. The future becomes not only dimmer, but lonelier. This matters because galaxies do not live in isolation from the wider structure of the cosmos. They feed, grow, collide, and evolve within a web of matter stretched across space. In the early universe, those connections were more active, distances smaller in effect, growth easier, But in an accelerating universe, the wider architecture begins, slowly and relentlessly, to thin in a different sense. Regions not already held together by gravity drift farther from one another. The great large-scale web does not vanish all at once, but its nodes become increasingly separate. And yet one of the subtler truths here is that dark energy is not the entire explanation for why the universe has grown quieter. Simulations of cosmic history suggest that even without it, star formation would still have declined substantially. Galaxies would still quench. Black holes and stellar feedback would still heat gas and sometimes drive it away. The cosmos was never going to remain forever in the exuberant state of its own cosmic noon. In that sense, the fading was already underway for reasons built partly into galactic life itself. What acceleration does is not replace that story, but deepen it. It makes decline feel less local and more final. It is one thing to imagine galaxies gradually losing the conditions needed to renew themselves. It is another to realize that the wider universe is also becoming a place of increasing separation, as though the spaces between the surviving islands of light are being widened by the very stage on which the drama occurs. For a while, this seemed to give modern cosmology a strange but workable clarity. The universe had a beginning. It expanded. Its early ages were more fertile than its later ones. Galaxies began to go quiet. Expansion accelerated. Put together, these ideas suggested a future with a recognizable shape. The universe would continue. Stars would become rarer. Great structures not bound together would slip away from one another. Light would persist for a very long time, but with less renewal. The ending, in that view, would not arrive as a sudden blow. It would come as a quiet and relentless drifting outward and downward, a cooling not only of temperature but of possibility. But science has a way of unsettling the answers it once seemed to secure. Dark energy may be the best name we have for the force shaping this late cosmic future, but naming is not the same as knowing. And once that discomfort returns, the neatness of the picture begins to loosen, because the question is no longer only whether the universe is fading. By this point, that seems difficult to deny. The deeper question becomes whether we truly understand what kind of future that fading belongs to. For some time, the most widely accepted answer to the universe's fate seemed, if not comforting, then at least stable. If dark energy behaves as a constant property of space itself, then the long-term future is not especially violent. Expansion continues to accelerate. Distant galaxies slip beyond one another's reach. Star formation dwindles. Existing stars live out their lives. Over absurdly vast spans of time, the cosmos grows darker, thinner, and less eventful. This is often described under the broad idea of heat death, though the phrase can sound more sudden than the reality it refers to. In practice, it means a universe drifting toward lower and lower possibilities for organized activity. That picture fits naturally with the quiet mood of the story so far. The universe does not explode into nothing. It does not draw a curtain in a single instant. It simply grows older and less fertile, then older still. It is, in a sense, the most patient possible ending. And yet, the longer one stays with that picture, the more one notices how much depends on a remarkable uncertainty. We do not actually know what dark energy is. We know how the universe behaves as though it exists. We know that the expansion of space accelerates. We know that the simplest model, matching many observations, treats dark energy as a constant. something like a fixed energy density of the vacuum. But that simplicity may be the truth, or it may only be the best current approximation to something deeper that we do not yet fully grasp. This is where the documentary's central question changes again. Earlier, it was enough to ask whether the universe might already be in decline. Then it became necessary to ask what had made that decline deeper and more final seeming. Now another layer opens. If the very force shaping the long future is not fully understood, how confident can we be about the ending that force implies? That is why modern cosmology, for all its precision, still leaves room for futures that do not sit comfortably inside one elegant picture. If dark energy is not constant but changes over time, then the ending may not be as quiet as the standard version suggests. One possibility, long discussed though not favored by most evidence, is the so-called Big Rip, in which accelerated expansion grows so extreme that over unimaginable ages it overwhelms larger and larger scales of structure. Galaxies would separate, then perhaps clusters, then stars, then eventually the smaller bonds that hold matter together. The idea has a natural grip on the imagination because it sounds so dramatic, but its very drama is part of why it must be handled carefully. At the moment, it remains more a speculative possibility than the sober expectation. Another possibility arises not from cosmology alone, but from particle physics. The vacuum of the universe may not be absolutely stable. It may be metastable, like a system resting for an immense time in a condition that is not truly final. If that were so, then an unimaginably rare transition could in principle occur, altering the laws and structures that govern the world. This is not the same as saying the universe is likely to end that way anytime remotely relevant to human thought. It is simply to say that even in the foundations of modern physics, the future is less closed than one might wish. What makes this uncertainty especially interesting now is that it no longer belongs only to old theoretical speculation. Recent observational work, including results from the dark energy spectroscopic instrument, has added fresh interest to the idea that dark energy may not behave exactly like a constant after all. These hints are not yet decisive. They do not amount to a settled overthrow of the standard picture, but they are enough to reopen the question in a serious way. Enough to remind us that the neat future of quiet expansion may be right and still not be final in the way we once hoped scientific answers could be. There is something almost beautiful in that return of uncertainty. Not because uncertainty is satisfying in itself, but because it restores humility to the story. We have learned enough to know that the universe changes, enough to know that its star-making age is behind it, enough to know that expansion accelerates, enough to understand that the future belongs to thinning, aging, and separation in some profound sense. And yet beyond that, the cosmos retains its old habit of resisting total closure. So by this stage, the question is no longer, in the simplest sense, whether the universe is ending. It is, at least if ending means the irreversible loss of the conditions that once made it richly generative. But if we ask what kind of ending this is, and what form that loss will finally take, certainty begins to soften. Apparent clarity gives way to deeper uncertainty. And once we arrive there, another question becomes unavoidable. Perhaps our ordinary idea of an ending was never really suited to the universe in the first place. Human intuition likes endings that can be pictured. A city falls, a fire goes out, a life concludes. Even when an ending is long, we still imagine it as moving toward some final scene that gathers its meaning into a moment. But the universe does not seem especially interested in providing that kind of clarity. Its endings, if that is the right word, may be distributed across scales so immense and processes so slow that the very idea of a single cosmic finale begins to break apart. Consider what the quietest standard future already implies. Galaxies continue for a very long time, but new star formation becomes rarer. Existing stars burn through their fuel at different rates. Large stars disappear first. Smaller, dimmer stars endure vastly longer. Black holes remain after many other luminous things are gone. And even they, according to Hawking's great theoretical insight, may not be truly eternal. Over timescales so long that ordinary language almost ceases to function. Even the darkest and most durable objects may slowly surrender themselves. None of this resembles a curtain dropping. It resembles a sequence of withdrawals. In that sense, the universe may not end in one place. It may end differently in different layers of itself. The age of abundant star formation ends long before the age of stars. The age of stars ends long before the age of black holes. The age in which the large-scale universe is easily visible from one region ends when distant galaxies slip away beyond observation. What we call the end of the universe may therefore be not one event, but the long unraveling of many different kinds of beginning. That thought widens the meaning of everything we have been following tonight. At first, the question seemed to be whether the universe had a future ending at all. Then it became a question of whether that ending had, in some sense, already begun through decline. Then it deepened into uncertainty about the force shaping the long future of cosmic expansion. But here, at the widest edge of the story, the question becomes stranger still. What if the universe does not really offer a final ending in the human sense, but instead passes through a succession of eras in which familiar forms become impossible one by one? What if the true sign of cosmic ending is not destruction, but the gradual loss of what the universe is able to be? That makes the night sky feel different once more. Not only older, not only quieter, more temporary in its particular beauty. The sky we know depends on an unusual combination of circumstances. Stars still abundant, galaxies still visible, heavy elements already forged, complexity still available, darkness not yet victorious. None of that was true in the earliest universe. None of it will remain true forever. We live in a cosmos that is not merely between beginning and end, but inside a special interval when light and structure still gather richly enough to make minds like ours possible, and to let those minds wonder what lies ahead. There is a tenderness in that realization, not because it makes the universe small or sentimental, but because it places us inside its history rather than outside it. We are not watching a timeless machine from a safe distance. We are inhabitants of one season of a changing cosmos, looking out from within its late light, trying to understand not only how vast it is, but where in its long life we happen to stand. And so, when we return at last to the question we began with, is the universe actually ending? The most honest answer is both simpler and stranger than it first appeared. Yes, in one profound sense, it is. Not because everything will suddenly vanish, and not because the stars above us are about to go dark, but because the universe seems to have already passed through a richer age and entered a long, quiet reduction in the conditions that once made it most fertile, the ending. If that is the word we choose, may already be visible in the slow fading of cosmic possibility. But the deeper we ask what that ending finally means, the more the answer loosens in our hands. The future may be a patient drift into cold and separation, or it may contain turns we do not yet fully understand. Depending on the deeper nature of dark energy, of the vacuum, and perhaps of time itself. And perhaps that is fitting. The universe has allowed us to know enough to sense its direction, but not enough to stand outside mystery altogether. Maybe that is why this question lingers, not only because it concerns the fate of stars and galaxies, but because it touches something more intimate in the human mind. We are creatures who live by noticing change, by feeling the passing of seasons, by sensing that beauty is intensified, not diminished, by the fact that it does not last forever. To realize that the cosmos itself may also have seasons is to feel both smaller and more deeply included in reality than before. So tonight, as the sky settles back into silence, perhaps the thought to carry with you is not that the universe is ending in some dramatic sense, but that it is alive with time, that it had an age before this one, and that it will have ages after us, each with their own forms of light and quiet, and that here, for a little while, in this brief and thoughtful interval, we have been able to look up into the late glow of a changing universe and wonder what kind of story we are already inside.